5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of an Atlas V rocket and Landsat 9, continuing the legacy of an irreplaceable 50-year record on our ever-changing planet.
Control system response looks good. RD-180 engine operating parameters continue to look good. Vehicle has begun the pitch over maneuver. Body rates look good.
That pitch over maneuver heading it to the south towards Southern California and down to Mexico.
Now passing 40 seconds into flight. Engine operating parameters continue to look good. Pump speeds and injector pressures all within expected ranges.
There's a shot from our tracker cam above the marine layer.
Now 55 seconds into flight. Vehicle is now completing the pitch over maneuver. Body rate responses continue to look good. 3 minutes remaining in the boost phase of flight. Pump speeds and injector pressures on the RD-180 continue to look good. Body rates continuing to look good. And at 1 minute 20 seconds into flight, Atlas is now supersonic, vehicle passing Mach 1.
A critical moment for the rocket.
And vehicle is now passing max Q, maximum dynamic pressure. RD-180 performance continues to look good throughout boost phase. Engine's now throttling down slightly as expected. Engine response looks good.
That throttle down reduces the stress on the 19-story tall vehicle.
At 1 minute 50 seconds into flight, vehicle is now 10.7, 13 miles in altitude, 7.9 miles downrange distance, traveling at 1,500 miles per hour. Now just under 2 minutes remaining in the boost phase of flight. At 2 minutes 18 seconds, the Atlas V vehicle now weighs just 1/2 of its liftoff weight. And vehicle's gone to closed loop guidance. Body rates indicating a slight adjustment can be expected for this phase of flight.
There's a beautiful shot right there, looking back towards the planet. And see the plume from the RD-180.
And the reaction control system on the Centaur is now pressurizing to flight levels. System pressure response looks good.
So the reaction control system on Centaur, they're prepping it.
RD-180 engine operating parameters continue to look good throughout boost phase. Body rates remain stable.
Coming up in 60 seconds, the booster engines will cut off.
Flight. Approximately 1 minute remaining now until booster engine cutoff.
Our tracker shot getting a great...
And now 3 minutes 15 seconds into flight. Atlas is 48 miles in altitude, 70 miles downrange distance, traveling at 5,600 miles per hour.
Great shot as it goes out over the Southern Pacific.
Pump speeds and injector pressures on RD-180 continue to look good throughout boost phase. And the Atlas V is now throttling to maintain a constant 5G acceleration limit. Engine response looks good.
Speed currently 7,700 miles per hour.
Has begun boost phase chill down. Now throttling to maintain a constant 4.6G acceleration limit in preparation for BECO.
This is where the booster engine cuts off and then separates.
And we have BECO booster engine cutoff standing by for stage set. And we have good indication of Atlas Centaur separation. We have pre-start on the RL-10, standing by for ignition.
And there you see the separation.
We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
Beautiful shot of the booster falling away as you're looking down.
And we have good indication of payload fairing jettison.
And you should see the payload fairings. Sometimes they come around the side.
12 minutes, 11 seconds.
There you see one.
RL-10 performance continues to look good in the early part of this first burn. Now passing 4 minutes, 47 seconds into flight.
So we're in a good point, Mick, Flight is looking good. We're going to monitor the situation here. But what a beautiful launch. What a beautiful flight so far.
5 minutes.
But there's still a lot of work to do.
Yeah, absolutely. A lot of work to go on, but beautiful shot there of the RL-10 engine in space, sending Landsat 9 onto its orbit. A great launch this morning. So excited for this.
We're getting some of that orbital sunrise on the engine bell there, and that's just a neat look as you look back at our planet. We are just seconds away from main engine cutoff. Centaur has been burning now for several minutes. It's really close. When this happens, we're going to be in an orbit that's a little bit higher. You just heard we're just about a minute out.
Yeah, so what's happening is we have this first burn, and we're trying to get a slightly lofted orbit this morning into that near-polar sun-synchronous orbit, Daryl, so that we can get Landsat 9 up there. What will happen is main engine cutoff will occur, and then we will coast for several minutes to get Landsat 9 into the orbit it needs to be, and then we will get spacecraft separation at L plus 1 hour and 20 minutes.
Hard to believe we're just a few seconds away from main engine cutoff, but hard to believe this spacecraft and this rocket have gone almost completely around the planet. Currently coming up through eastern Africa over Turkey. We're just seconds away. Let's listen in to the call for main engine cutoff.
And we have MECO, main engine cutoff. Body rates look good. The vehicle is now recovering from the shutdown transients.
And there you go, Daryl. We heard from United Launch Alliance commentator Patrick Moore, who's done a fantastic job since liftoff of filling us in on all the activities that have been going on, and we just got confirmation of main engine cutoff. So Landsat 9 and the Centaur will coast for a little bit, and then we're about an hour and 3 minutes from Landsat 9 separation.
Yeah, it'll coast for a lot of it, right? Because as you can see in the bottom of the screen, we have removed our progress bar with the milestones and now have a new progress bar, which will show you the time to spacecraft separation, which you can currently see is set at an hour and 3 minutes. We'll be monitoring everything here. Time now until separation. We're dealing with a little bit over 3 minutes until that moment happens. And so let's talk a little bit about that, Mick. How exactly does Centaur separate from Landsat 9?
That's actually a cool little thing that happens is when it's time to separate, Centaur will send a signal to a device that's up there as part of the Marmon clamp that will release the separation bolts. And this Marmon clamp that is tied around, as you saw earlier in the upstand video, tied around on the bottom of Landsat 9, it will release that clamp, and Landsat 9 will then be pushed away using some separation springs. Very little force that is needed to get Landsat 9 going on its way for separation. So very simple design, but took a long time to do. Our mechanical engineers have been following this as they mated Landsat 9 to this the Marmon clamp, and it made sure everything was right from a tension and perspective, and you know, we're just looking forward for that set moment.
And we're watching now an animation that is tied to real-time data, so we'll see that moment. You know, it's interesting, you talk about springs putting it in the final moment. It takes rocket engines to get it up there, right? It takes rocket engines to get it close into orbit, but it does its final move with springs.
Yeah, absolutely. You know, we need all that thrust and power to leave Mother Earth and get out of her gravitational pull. But once we're in space and orbit, it takes very little work to make things happen. As we have watched Centaur and Landsat 9 orbit in this coast phase, we've seen the reaction control system just maintain Centaur in its space. So we're doing good, and that's just how rocket science works.
Yeah, just about 70 seconds away now as we're counting down until Landsat 9 separation from Centaur. Once this happens, though, Mick, there's still more mission to go. There's some CubeSats on board.
1 minute.
Yeah, absolutely. Landsat 9 is our primary mission today, and once we separate Landsat 9, Centaur will begin its maneuvers in chilling down again the RL-10 engine and getting ready to restart, or what we call main engine start 2, for a few second burn there. And then they will do a MECO, main engine cutoff again, and then we will do a third burn to get into the trajectory and orbit that we need to deploy the two CubeSats that are on board. And Daryl, you had mentioned earlier in the show today is a first for us also on Atlas V with a 4-burn. We will do that 4th burn to dispose Centaur and not leave it in space as space junk.
A point of history for the Atlas system and Centaur. We're listening now to see.
And standing by for spacecraft separation shortly.
Let's listen in. We are expecting spacecraft separation at any moment.
And we have successful separation of the Landsat 9 observatory.
And there you go.
So excited for that. I mean, so happy to hear that. That is just exciting to see Landsat 9 on its way and continue that 50 years of data.
And there she goes. An impressive sight. It is an animation, but here at the Mission Director Center, there was some applause behind us for the people gathered here. It's a nice moment for them. It's a nice moment for you.
Yeah, absolutely. We applaud, but it wasn't a huge celebration yet. I mean, we're very happy Landsat 9's on its way, but as we were just talking about, the mission's not over yet. We still have CubeSats to deploy, and we want to follow this through for mission success for all of the payloads on board today. But that is a huge milestone to get Landsat 9 on our way.